At the end of the topic, you will be able to define and interpret heat and temperature, explain the change of state, study the effect of heat on physical and chemical properties of the substances, demonstrate thermal expansion in solids, liquids, and gases.
Heat has been one of the very first forms of energy man has been using to survive. To keep oneself warm or the cold, we need to adjust to the temperature around. Yes, temperature is the measure of heat. It is the imbalance in nature that makes life possible. All processes around us like rain, sunshine, breathing, wind, and cooking happen due to heat. Let us learn more about it. Heat is a form of energy that flows from hot body to cold body. Temperature expresses the degree of hotness or coldness of a body. All objects in this universe are either hot or cold. When we touch a hot body, we feel it hot as our body gains heat. Similarly, when we touch a cold body, it takes away the heat from us and we feel it cold. A cooking vessel becomes hot, taking the heat from the flame of the stove. An object placed in the refrigerator becomes cold, losing its heat away. So, we conclude saying that heat flows from a hot object to a cold object. Heat is a form of energy which always flows from the hot object to the cold object. Temperature is the measure of the degree of hotness or coldness of the body. When a body gains heat energy, its temperature increases, and when it loses heat energy, its temperature decreases. Heat is the cause and temperature is the effect. We normally see things in three states, namely solid, liquid, and gas. Stone, rock, wood, ice, and wax are in solid state. Water, milk, juice, and oil in liquid state. Air, oxygen, and nitrogen are in gaseous state. Those substances are in a particular state at a time, certain changes around them change their states. For example, water when heated turns into water vapor. If it is placed in the refrigerator, it turns into ice. Similarly, if the air in a room is liquefied, it can be filled into a bottle. All substances can be converted from one state to another when temperature changes are there. Even the rocks and stones will melt at high temperatures produced during the atom bomb explosion. The constant temperature at which the solid turns into a liquid is known as the melting point. The constant temperature at which the liquid begins to boil is known as the boiling point.
When substances are heated, its physical and chemical properties also undergo changes. Let us discuss a few examples based on the physical and chemical changes. Physical change. Zinc at room temperature remains brittle and hard. On heating, it becomes soft and flexible. Iron on heating becomes soft and can be changed into desirable shape. The electrical resistance of a conductor increases on increasing the temperature. A magnet on heating loses its magnetism. Chemical change. The speed at which the chemical reaction takes place depends on the temperature of the substances involved in it. In other words, heat facilitates chemical reactions. For example, calcium carbonate, which appears white solid, on heating decomposes and produces carbon dioxide gas, leaving a white solid called calcium oxide. Let us discuss one more effect of heat called expansion. When we heat a substance, it expands and contracts on cooling. Metals expand when it is heated. See this animation. That will help you to understand more on the effects of heat. From this animation, we can understand that metals expand when heated and contract when cooled.
There are a number of applications of thermal expansion. For example, railway lines are laid with small gaps. When temperature varies, the gaps allow the iron tracks for maximum possible expansion. Telephone lines are laid with extra length so that they don't break due to contraction in winter season. Small gaps at the joints are used in bridges to accommodate thermal expansion.
Let us see the expansion of liquid due to heating. Take colored water in a glass tube. Heat the glass tube by keeping it over Bunsen burner. The level of the colored water goes up in the capillary tube while heating the glass tube. The level of the colored water comes down while cooling. This shows that the liquid expands on heating.
Now we will discuss the thermal expansion of gases. Thermal expansion of gases is more than that of solids and liquids. Take a long capillary tube and trap a few drops of colored water in between the capillary tube. Insert the tube in the single-holed rubber cork and fit it into the empty round-bottomed flask. The gap between the cork and the flask is sealed with wax. Arrange the apparatus on a stand. Now heat the flask using a spirit lamp. The trapped colored liquid moves up when heated and moves down when cooled, because the air inside the round-bottomed flask expands on heating and pushes the colored liquid up, and when cooled, the gas contracts and the external air pressure pushes the colored water down in the capillary tube. Gas expands more when compared to liquids, neglecting the expansion of the container. Therefore, as seen, all matter, that is solids, liquids and gases, expands on heating.
Now we can say that all substances, solid, liquid and gas, expand on heating and contract when it is cooled. On comparing the extent of expansion of these substances, we realize that gases expand more than the liquid and the liquid expands more than the solid. In this topic, you have learnt heat is defined as a form of energy which flows from a body at high temperature to a body at lower temperature. Temperature expresses the degree of hotness or coldness of a body. The constant temperature at which the solid turns into liquid is called melting point, and the constant temperature at which the liquid begins to boil is called boiling point. Solids expand on heating and contract on cooling. Gases expand more than liquids, and liquids expand more than solids on heating. At the end of the topic, you will be able to list down the three modes of heat transfer, explain the process of heat conduction in solids, state heat convection in fluids, describe the process of heat radiation.
Heat transfer refers to the movement of heat from one place to the other place. Let us understand heat transfer. Take an ice cube. Keep it on your palm. What happens to the ice cube and how do you feel? Ice starts to melt and you feel so cool. This is because heat is transferred from your palm to the ice. Ice is in a cold state and your palm is in comparatively hot state. Therefore, heat is transferred from hot to cold. In other words, heat flows from high temperature to low temperature. Temperature is the measure of hotness of a substance. The science of how heat flows is called heat transfer. There are three ways that heat transfer works: conduction, convection, and radiation. Transfer of heat exists till there is temperature difference between the two bodies. Now, we will discuss the transfer of heat by conduction. Take a straight aluminium rod. Fix some matchsticks on the rod with wax. Fix one end of the rod on a table. Now, heat the other end of the rod using a candle. The stick near the candle falls first, followed by the next nearest stick, and so on. It shows that heat supplied by the candle flows from one end to the other end of the rod by conduction. Click the animation button to learn more about conduction. Conduction is the transfer of heat through materials by the direct contact of particles in the metal. Metals like copper and aluminium are very good thermal conductors. When you heat the metal, the particles in the metal start to vibrate. These vibrations make the adjacent particles to vibrate, and so on. Thus, the vibrations are passed along the metal. When we heat a metal strip at one end, the heat will flow to the other end by means of conduction. This illustration will help you to understand the concept of conduction. Conduction of heat differs from substance to substance. In some materials, conduction of heat takes place very fast. They are good conductors of heat. Silver, gold, and aluminium are good conductors. Wood, leather, asbestos, paper, glass, and mud do not conduct heat. They are bad conductors and are called insulators of heat. We have learned that heat transfer takes place from a body at a higher temperature to a body at a lower temperature. Do you know how heat transfer takes place in a liquid? Molecules of liquid get heat from the flame through the bottom of the vessel and start to move up. The cool molecules come down to absorb heat and move up in a cyclic manner. Heat transfer takes place with the movement of molecules in the liquid. The flow of heat with the actual movement of molecules of liquids and gases is called convection. Because of the heating effect, the liquid at the bottom expands and becomes less dense. The cool liquid at the top becomes comparatively denser. The heavy cool liquid moves down. Therefore, the difference in densities at different parts of the substance is responsible for the transfer of heat through convection. Why is it always windy at Seaside? The reason is the air above the land gets heat from it. Therefore, hot air moves up, and the air above the sea is always cooler than the air above land. This cool air moves to the land to take the place of hot air that has been rising above. Earth receives heat and light from the sun. Do you know how heat gets transferred from sun to the earth? Since there is no material medium such as solids, liquids, and gases between sun and earth, conduction and convection is not possible. So, heat gets transferred from sun to earth without any material medium. The transfer of heat energy without any material medium is radiation. When you stand in the daytime in the open field, your body becomes warmer and perspires. This is due to transfer of heat from the sun by radiation. Most of the space between the sun and the earth is empty, so heat radiation travels through vacuum. Stand near an oven or a furnace. The hot air moves up, so you will not get heat from air. Still, you feel warm. This is due to radiation of heat that travels in all directions.
In this topic, you have learnt heat can be transferred in three ways, namely conduction, convection, and radiation. Conduction is a transfer of heat through materials by the direct contact of particles in the body. The transfer of heat due to the actual movement of molecules is called convection of heat. The transfer of heat without any material medium is called radiation of heat.